Okay, welcome back everybody to the last live stream from Devoxx Belgium. The conference is already shutting down. You might hear some background tearing down noises, but the sessions are still going strong to the middle of the day. And we have here Per-Ake Minborg, which we just discussed, maybe the leader of you and Anna, our colleague Anna, gave like 4 talks each.
Yeah.
Which is crazy.
Yeah, it's really crazy. So I'm looking forward for the weekend now.
Yeah, I can see. But you can see how much there is to share, right?
Yeah.
Before we got into all that though, Per, why don't you introduce yourself for those people who may not know?
Yeah, so I've been around since Java 1.0, so that makes me, an old man.
What do you mean, like around, like at Sun? And then
No. So
just like
I have worked in several startups in the past decades and writing open source libraries for Java. And so I got started at Oracle 2 years ago, and now I work in the core library libs team. And I've been working with Project Panama a lot together with Maurizio and Jorn the last time. And I'm also working with a new thing that's related to performance, which is called stable values. Okay. Very interesting thing.
Yeah, you gave a talk about that here that went really well, right?
Yeah, I did. So that's going to be very interesting and see how people like that.
Yeah. So if you're not excited about this, we're not going to talk about that though. I got something else on the menu for today. But the stable values talk will be on the Devoxx channel if it isn't already, and will definitely be on the Java channel too, so people can watch it there. But you gave a talk about Java Performance Update.
Yeah.
That was the title of the talk, Java Performance Update, which seems to suggest that there's like a reason to regularly update people on Java performance characteristics. So why don't you give us like a rundown of what that was all about?
Yeah, so I did actually a similar talk last year, and of course this year there are so much new that we have improved in the JDK. That's worth mentioning, I think. We have put a lot of effort into Project Leyden, which is not about performance of method, as you know, normal performance. I think our string, toString is improved by a factor of 2 or something like that. Yeah. But Leyden is all about startup time and warm-up time. Yeah. So if you, for example, have a web app that you have deployed on web server somewhere, it might be very important for you to be able to start it quickly. Maybe you have the situation that they have a low frequency site, and then you're able to wind down and don't use any server. That's true serverless. And when there is and when there is a call, you can just spin up the Java application. Yeah. But as
Java's not exactly well known for that.
No, precisely. But with Project Leyden, it might be. Because we can cut down the startup times significantly. I don't want to promise any figures, but I think we can see a fair amount of X improvement in the startup, depending on what application it is. And I think as we go along, it's not only about startup, but also about warm-up. As we all know, it takes a while for Java to compile, to gather statistics, like profiling data. And once we have that all profiling data, we can do a very effective compilation. But with Leyden, you can do a test run before, a pre-run, and then you can store that information on the profiling data, and maybe also the compiled code. And when you start up from a cache, you're good to go from second 0, basically.
Yeah. Can you distinguish startup and warm-up for the audience if they don't know the exact details?
So that's a very good question. So startup is the time it takes from when you deploy your web application, for example, until you can do any useful work.
So like main starts, basically.
Yeah.
When the main method starts executing.
In a very simple example, it's if you write a hello world application, and when you press enter, it's time before you can see hello world on the screen. Yeah. And we know that's all a few milliseconds before you can do that. And if you have a bigger, web application, it takes much longer because you have to do all this wiring of components and opening sockets and all that stuff. So that is startup. Warm-up, on the other hand, is the time it takes before you have peak performance. And that is usually, seconds or maybe minutes, depending on how many incoming requests you have. And that might be very important if you have, let's say you have 10 web servers up and running, and then you need to scale up performance and you add 2 more. And then you don't benefit so much from those 2 new until they are warm. Yeah. So that's kind of important because they can even get clogged. Before they get up to speed.
So warm-up is also, isn't it also like a little bit unpredictable? So if I have let's say I have 10 paths through my app, and like the first 6 I used immediately. Yeah. So then if the other 4 are kind of independent, then they don't, it's not like warm-up is one thing and then it's done, right? So if the first 6 get used a lot after the startup, they will warm up quickly. Yeah. And the other 4 could still be not jitted, not compiled, so they if the first person who takes that route might still fall into performance hole, right?
Yeah, exactly. So that's why it's important to have kind of a long run. Then you're able to gather more statistics, and then you're able to reach those maybe corners of your code. So what you can do is that you can write an integration test that actually covers all those corner cases and make sure that the code is warm. And once you bring it down, all that cached thing are stored in the AUT cache. That's the name of the thing we're working on, the AUT cache.
The ahead of time cache that will contain basically everything that you might need to make startup and warm up faster, right?
Exactly. But the thing is that we will not get this in the first spin. And maybe we will see in 24 or 25 that we are storing just the classes, the mirrors of the classes, and dynamic binding, and maybe some enum classes or pre-initialized and stuff. But there is this great roadmap when we're going to push down this, more and more data into the AUT cache, and we will see that performance will increase as we go along.
Okay. Have you watched Brian's keynote about the peak of complexity and all that stuff? Yeah, that sounds like the youthful optimism in the beginning that he points out. We have this great roadmap, and it's all going to be
we have this great ambition with Leyden from the beginning that we are going to have condensers that will transform code and all that stuff. But I think eventually the AUT cache will give us so much without doing any changes to programming model or anything like that.
Yeah, that's really interesting, right? So when Project Leyden set out, it was basically the assumption, well, we can probably only give you performance if you give something else up. Or we can only give you significant startup and warm-up time improvements if you give something else up. And then the more you give up, the more improvements you can get. And then I talked to John Ross about this for a couple months ago, and he said as well, once you had like a critical amount of people working on this and pushing this, it turned out maybe that's not even necessary. Or maybe that's definitely not necessary now. It might still become necessary later. But
we still have those tools, so we can look at them later. But I think it's better to have these kind of low-hanging fruits first and keep Java as compatible as possible. I mean, Java has always been this, works on any platform and all that stuff. So we don't want to, sacrifice that. Yeah,
specifically not prematurely, right? If it turns out that you can push quite a way without having to make those sacrifices then. And also it's also easier for the user, right? If I would have to make these trade-offs, then I would have to think about those trade-offs. When there are no trade-offs, I just press the button and it's faster.
So in earnest, anything you sacrifice is that you can't redefine a class really early. That's the only restriction, and I think that's very rare out there. So I think virtually you don't give up anything.
So that would be like agents redefining classes, for example?
Yeah, I think so, and they will not have effect early, because when you boot up, this is what you have. You have the mirror of what you had when you kind of pushed it in the AUT cache.
So you mentioned 24 and 25 just now. So can we hope to see the first things in 24?
I think we can.
I asked hope, so not promises as always.
Exactly. I think it's reasonable to hope that.
Okay, good. I'm known for my unreasonable hopes for when things will arrive, but that's good. I'll
but it wouldn't be a fun world if you weren't an enthusiast or optimistic about things. So we might see it, and I also think that the stable value that I talked about might be in 24 as well.
Okay, look, since we touched on it twice, why don't you give us like a 2-minute primer on what a stable value is?
Okay, so stable value is like before, even since Java 1.0, we had final fields and we have non-final fields. And final fields are immutable. That is, you set them once and then they never change, or at least
through the language, right?
Yeah. And then we have the mutable fields that can change at any time by any threads and so on. And it's the JVM can't optimize it because it cannot trust that the value will stay as it is.
Yeah.
So there's always this tension between immutable fields and mutable fields. And the thing is, with immutable fields, you have to set them at very specific time as you create an object in the constructor or in the static class initializer. So you're very constrained there. You can't set them later. So there is this tension between those two. And stable value now comes in and introduces a third kind of category of field. So it gives you basically the advantages of both immutable and mutable. And we call this deferred immutability.
Yeah, okay, that makes sense. Specifically, if the initialization of this immutable field is expensive, you really don't want to do it early, right?
Yeah,
you want to defer it until it's needed.
So a very typical case is that you initialize a logger. That's just one line of code, but in reality, it might go out there, parse an XML file, maybe prepare storage, create a directory, set up log rotating and all that stuff, or even maybe connect to a database. And that takes a huge amount of time. And if you have 10 components having their own loggers, performance with startup is going out of the window totally. But now you can say that, well, here is how to create my logger, but I don't want to do it now. And then as soon as you reference this, the value will be set automatically for you using this lambda that you provide. And the VM can trust that this value is never updated anymore. And it can constant fold it. So you get constant folding and full flexibility. So developers no longer have to choose between flexible initialization and performance.
I definitely have to look into that and into the API too, because I've, obviously without all the JVM improvements, but I have implemented like that in the way before times. I think when Java 8 came out, I realized I often have to lazy initialize fields. And so I set up like a little lazy class that you just give it a function, and the first time you call get on it would execute the function and set the result to a field so you can later return it. And just saying, basically it's kind of like that, but JVM, as you said, can trust this, it won't change.
Yeah, so this is not something a regular Java developer can write. You can write a lazy class, like I just explained, but that lazy class won't be trusted by the VM.
Exactly, it doesn't know that this non-final field might not be reassigned.
So we have this secret sauce that we have added in the VM that, this is stable value. I trust that this will never update. And so we have this kind of great fusion between mutability and mutability.
I think that's also a great example, by the way, of sometimes I talk to people and they ask me like, why would is this in JDK, or could this be added to the JDK as an API? And one of the criteria, it's not a requirement, but it's a strong indicator that something should go into the JDK is if only the JDK can do it.
Yeah.
So my lazy thingy, everybody can clearly build that, but the lazy, it integrates with the JVM in a way that makes the JVM optimized for this.
Yes.
Nobody outside can do. That must happen in the JDK.
Yes.
So that's an indicator why it should be in the JDK. And otherwise, if it can be outside and if there's no big need to like have a custom alignment across the ecosystem, much functionality can just be left to libraries.
Yeah,
I
think so.
When you said, though, I was kind of hesitant in joking about final because the problem with final is that reflection can actually work around that. Set accessible true, you set final fields, and that is actually an issue for many optimizations, right? That even though the field is final, it could technically still change. Is the same true for the stable value, or is that final? Like, because the record components are final, right?
Exactly. So the record components are final.
Yes.
In the sense that we have some safety net around it. So you can't, set accessible true. You can't even use unsafe to get its offset.
Yeah, nice.
And what we did was that we added the same kind of safety net around stable value.
Okay.
So they have the same degree of protection as records.
Okay.
And so they can be trusted as records.
So even more, then that means that I might actually get better performance out of the deferred immutability because it sidesteps this long-standing. I mean, it's not a bug; it's like in the spec, right? But this let's say this lack of strictness where final cannot really be trusted by the JVM.
Yes.
Okay, so
I think there is a reason why we don't trust final fields are final, because we have these old. I will mention the S word here, serialization.
That too. Oh my God! Again.
That's the reason. So it's coming up and biting us again.
Okay.
So I think eventually we are going to be able to trust normal classes as well to be actually final. Okay. And I think the utility of stable values will increase even more than.
Okay. Now maybe we're going down a rabbit hole, maybe. But my understanding is that. Doesn't the spec allow changing a final field via set accessible? So wouldn't disallowing that be like an actual change, like a backwards incompatible change in the spec, or is there another way to get around that?
Well, maybe.
Maybe. Okay. So we're getting too far into the murky future territory.
But before we leave stable value, another cool thing is that if you have a stable value that references another stable value and so on, and then you can establish a chain of trust. So then you can collapse all the computation through several. So a very typical example is that you have a web component, and then you have a logger and ask, is this logger active? Yes or no? And then you have, if that is true, you have a lot of code. And now the VM is going to eliminate the entire code block for you, and you don't even have to worry about that, because it will be able to constant fold and see that, well, this code will never run, and so there's no use to compiling, so just throw it away. Okay. So that is great for performance.
So what I get from stable values is clearly the performance part, but I also get a nice API that makes it easier for, hopefully, and I didn't look at it yet, so maybe I'll get back to you on that.
Yeah, good.
But I also hopefully get a nice API that makes it easier for me to express this laziness behavior, so I can more easily just say, well, this is how it's set up, I'm not going to worry about when exactly it's going to be set up. It's going to be set up in time for me to use it.
Yeah.
But okay, so that's also nice.
So we have not only stable value, which is a single value. We also have stable collections and stable functions.
Really?
So let's say you have.
I really need to look into that.
Yeah. So you have a stable list, say,
Okay.
and then you say up front, I have a list of say 10 elements, and here is to produce the elements. That's the recipe. But I won't produce them now. And then you can just submit that list to any interface that takes the list. And you don't have to worry about that. And when you are first time calling that element, it's produced for you using that Lambda.
Okay.
And it's guaranteed to work even in a multi-threaded environment. And it's immutable.
Yeah, that was actually my challenge, by the way. Implementing that lazy was super simple until I was like, but what about thread safety? And I also implemented it in a monetic way, so you could apply more functions after that.
Yeah.
And then it quickly became so under threading, how does it work out? So yeah, the threading part was making my code more complicated there as well. So that's good.
Yeah, so that stable value is able to reason about not also collections of stable values, so that it's able to constant fold those collections as well. So if you in your code have like this lazy list.get5, that will be constant folded that value or whatever it is. So you might as well just if you have a cache of let's say square roots or whatever you have, and then the value of that square root will just inserted in your code and used as a constant value.
I think it's probably also important to point out that nobody's lobbying for everybody using stable list instead of list now. This is probably a very specific places where you want to use this. It is a performance consideration mostly, right? So it should probably follow after performance benchmarks show that there's a reason here to use that. Not everything is going to be stable values from your
exactly. So I think this is the case with every feature. I mean, it has its places. There are pros and cons, and there are certainly places where you should use it, and there are certainly places where you should not use it.
Yeah. Is there a JEP on this?
Indeed, it is. And actually, we.
Do you know the number? Is it already? Does it already have one?
It doesn't have a number yet.
It's
a draft. But yesterday we kind of approved. We sent it to Mark for consideration.
Oh really? Okay, so if you're watching this the week after Devoxx, if you're a straggler coming in here late, maybe you already pinned a comment down there that links to the JEP. You know what, actually we can also link to the JEP draft, right? So after this is done, I'm going to link to the JEP draft.
Link to the JEP once it appears.
Yeah. So yeah, that sounds really interesting. I want to look into that. But the trade-offs also, JPG knows how to write JEPs, but that the JEP probably explains it as well, that this is what the trade-offs are, for example, what to consider.
Yeah.
Okay.
That's great.
We don't have any questions in chat that I can see. We walked over two of the topics that you mentioned, stable values and Project Leyden.
I can talk about the improvements we did in the FFM API maybe.
Okay, yeah. Give us like 2 minutes of the FFM API improvements, and then we're gonna.
So in the form function in API was made final in JDK 22. And now we have optimized some of the bulk operations like fill, copy, and mismatch.
Okay.
That typically can work with, memory segment can illustrate a memory segment that is very big. Before we only have int index, but now we can have a long index, so we can have like gigabytes or even terabytes of data, and therefore it's very important that those kind of bulk operations are performant. And we discovered that they are written in the machine code or intrinsic code, but surprisingly, we discovered that it's faster if we write them in Java.
Really?
So that's really a surprise. So
the JIT is that good that it's better than the intrinsic code.
At least for smaller values, because there is always a price to pay when you transition from Java code to native code.
Okay, yeah.
And so we introduced thresholds there. So say it's less than 64 bytes. We don't pay the price to transition to native code. We just do it in Java.
Okay.
And that is more performant, and also it's better for checkpoints and pinning of stuff when you have to transition to native code. So that gives us not only performance but kind of a hygienic features as well.
Okay.
And we think that we're going to push the Java compiler even more, so we are able to push up these thresholds, and maybe we will end up in a situation where we never transition to native code, when Java always is faster.
Okay.
So that's interesting.
I think that's also something that people should look out for. If something new like the function memory API comes out, same is true for Lambdas, for example, back in the days. When new features introduced, it's introduced in a state where it's functioning, where it's correct, and where it's performant enough, but it's not optimized to the full degree, because nobody's going to defer a feature that is done for 5 years to get all the possible optimizations out, right?
Yeah.
So many features still get faster after they're released. So if somebody checks the foreign function memory API and says, okay, there's for whatever reason, there's a couple % here that I can't really make do and still need to look for alternatives, it's definitely worth it to check in every new release and see whether those numbers change, because they do.
Yeah, and I think one of the best feedback that the community can give us is feedback. Maybe we don't always appreciate a PR, but we appreciate people giving feedback to why I tried this corner case, but it turned out to be slow. Why is that? That's something we really appreciate.
Yeah.
So
especially like I have, let's say like, oh, this turned out to be slow, so I make a little benchmark, and this is so something like that.
And then we realized that we didn't cover that case, so then we can improve the code.
Yeah.
So that is really great feedback.
Another chunk of performance improvements is probably GC improvements.
Yeah.
I talked to Stefan Johansson about that yesterday. His stream is already here, so you will find it around the Java YouTube channel. People can look at that. And yeah, I think with that, I want to thank you very much for being here, Per.
Thanks for having me.
Sure. I want to thank everybody for watching this. We've had 8 great streams from Monday to today. I did catch Brian yesterday. We did record a really cool conversation about the peak of complexity and the virtuous collapse and all that good stuff. It's going to go live at 5 p.m. Central European Time, 3 p.m. UTC, as the live streams were today in the afternoon. By that time, we've been kicked out here long ago. Devoxx has shut down. Most people are on their way home, because some people do stick around for maybe a weekend. And this has been exceptional fun. I want to thank everybody who has been here. Setting up these live streams, walking around with David. David, do you want to come here? David doesn't want to come. He's like, he's busy. He has to click buttons afterwards. So yeah, this would not have been possible without David specifically, but also obviously the Java Platform Group of Oracle doing all the great work and then also coming in to talk about it. So yeah, I had a blast. Thank you, everybody. You now here as a pass pro total for the entire JPG. Thank you, JPG, for
thank you
for doing all this good stuff. And watch the premiere later of Brian's talk. I'll probably be in Czech while it's happening, assuming that train Wi-Fi allows me to. And then I'll see everybody there. And yeah, have a good one. Bye.
Bye.